Let me share the screen with you. So I'm presenting here at my academic capacity at the Reichman University. And we talk about AI and artificial intelligence. We need a lot of data. In genetics, if you want to understand a specific disease, you need to get genomes from hundreds of thousands of people to millions of people to really dissect the genetic architecture of the disease and to accumulate a lot of data. And what we're going to speak in my conversation is how you can use, like, what's the privacy issues of genetic data, and what you can do to protect genetic privacy. So our talk begins with the advent of consumer genomics. We have multiple companies that offer these days the ability for individuals to learn about their genome. They democratize access to genomic data, and it's a lot of fun to learn about your genome, where you came from, and so on. One of the most popular features in genetic genealogy or consumer genomics is the ability to find relatives. Let's see how it works. Here we have a pedigree. The circles are females, the squares are males, and in this pedigree we have 2 third cousins over here, and they shared great-great-grandparents. Now, these great-grandparents have chromosomes that they give to their kids, and these chromosomes basically break and transmit it to the next generation, and what you get in the final generation of these 2 third cousins are regions in the chromosomes that are identical. They were inherited from the same individual, like this red region over here and the green region over here. So if you screen the chromosome, you find suddenly a burst of nucleotides that are just identical between 2 individuals. We call these regions identity by descent regions, or IBD segments. Identity because they're identical, by descent because they're from the same ancestors, and segments because there are stretches of DNA on the same chromosome. We can develop a parametric model that will look at the number and the length distribution of these IBD segments, and from that we can estimate the genealogical relationship. And it works surprisingly well. What you see over here, this is from a manuscript in 2011, genome research. Here, this is the power to detect a relationship as a function of the cousinship, first cousin, second cousin, third cousin, and so on. And you see that we can detect, using this technique, over 80% of your third cousins, which is quite amazing, right? Like, most people don't know who are their third cousins. So if you and your third cousin come to my database, every day we can screen all the newcomers to database against the existing individuals, find these IBD segments, and tell you have a third cousin. Why don't you guys meet and speak with each other? And the power of this technique is quite dramatic. We know about the community, many success stories of people finding 2 half-sisters separated at birth, finding each other using this technique. A father and his daughter found each other, 2 Holocaust survivors, and so on. It's a very powerful technique that brings people together and change their life for good. Now, there is one problem. If you come to take a test with company A and I take a test with company B and we don't end up at the same database, we might not find each other, right? So basically each company creates kind of like a silo. So the genetic genealogy community solved this problem basically by letting individuals to upload their raw genetic data, which is just a file, right? Your file with the results of your genome. It's a very long text file. I just show you the very first few lines of your chromosome, the position of the specific nucleotide, and what alleles we got there. You can take this text file and upload it to one of the following websites. And these websites will allow you to search for more individuals. So you don't need to take a new test, you just upload. And by taking this, basically just your digital information, you can look for more individuals. Now, I want to emphasize the high importance of this technique. And what you see over here, this is a guy that he looked for his birth family. He's adopted from Brazil in the 80s. The adoption records were inaccurate, so he couldn't trace his birth family by regular genealogical tracing. He took a test, and with one company was not able to find any relative. At that time, I was the CSO of MyHeritage at full time. I told him, why don't you upload your data to MyHeritage? Maybe you'll find more relatives. He uploaded his data to MyHeritage and was able to find his half-sister from New Zealand, who also uploaded her data. So these third-party uploads are very important, and we're able to find for the first time for this guy his birth family. And this case is very dear to me because this guy is my first cousin, who is an adoptee, and we're able to solve the mystery of who is his birth, to connect him with one of his birth families. Now, here is the thing. At MyHeritage, we don't allow you to upload data if you don't have the consent of the individual. You have to sign that this data belongs to you and you have the consent to upload the data. Other websites, such as GEDmatch, for instance, they allow everyone to upload their data without any terms and conditions at that time when we conducted the study. So let me just, sorry. Can you see my screen? Yeah, okay. So let's go to this slide. Now, so the ability to upload the data to GEDmatch, the FBI also heard that you can get genetic information, you can get these text files that I mentioned before, and you can just upload them to GEDmatch to find relatives. So they took the DNA of the Golden State Killer, one of the most notorious criminals in the history of the US. This guy murdered over 12 individuals and raped dozens of women. They searched after him for nearly 30 years with no avail. They couldn't find him in any police database. They had a lot of his DNA because he left semen in many of the crime scenes, but they could not find any match in the police databases. So they took his DNA, they created a text file like the one that I showed you, uploaded a text file to GEDmatch, and found a hit to a third cousin. Then they employed a group of genealogists for a few months to build one of the world's largest family trees, mapping all the different third cousins that could match to the guy that they had a hit. And eventually they were able to find an individuals that really matched the profile of the Golden State Killer. He was in his 70s, and this is what they estimated about his age. He lived in North California, where he operated. He had also a background of being a police officer, and he knew that the Golden State Killer knows quite a lot about police work, so they suspected that he has some police background. Then they took a DNA test from the knob of his door, found a perfect match to the crime scene, arrested him, and brought him to justice. And now he serves life at one of the California prisons. So this is a quite powerful technique. And since then, the police department and the FBI in the US have started using this technology quite frequently to identify individuals. And there are now, I just put like a few cases, but there are hundreds of cases now that were solved using this technology. And we ask ourselves, is this the people that you can find with this technique? Is this just pure luck, some lottery tickets, or you can do it to every person in the population? So to study that, so at that time I was at MyHeritage, so we decided to conduct an academic study on that. We had in our database at that time 1.28 million individuals. To estimate the success rate, we took one person from the database at random, compared it to all the other relatives in the database, and looked who is the closest relative. Now, there is one kind of like tricky part, because individuals in our database, usually they come as families. They buy a kit, a DNA testing kit for themselves, for their mothers, for their sister. So we excluded all the close matches above 700 centimorgan, meaning first cousins, and closer than that, we just excluded. And we looked for the next match after that. We repeated the process for 1.28 million times. You see here the probability of finding a match as a function of the genetic distance. And genetic distances, I will not go over the definition, what is centimorgan, but I will just tell you that between roughly 100 to 400 are second cousins, between 0 to 150 are third cousins, between 0 and about 100 are third cousins once removed. These are the third cousins of your parents, and so on, right? And what you see is the probability of success. And what we found is that we estimated for the US population, you have about 60% chance of finding someone who is a third cousin. So give me a person at random of the US population, many of European heritage. Let's put this DNA in our database. We'll have a 60% chance that the best match would be a third cousin or closer. We repeated the same process also with GEDmatch, with their website. It's a different database, and we got very similar results. So 60% chance of finding a third cousin. Now, after that, there was a kind of like a tiny study, but this tiny study confirmed or was consistent with our expectation. In this study, BuzzFeed tried to identify 10 volunteers, and they were able to identify 6 out of the 10, which matches our 60% projection. It's quite nice to see that. Okay, so now the question is, we conducted a study in 2018, but these databases keep growing. The question is, what is the probability to find a relative for any given database? Can we do an analytical prediction? And we collaborated with Shai Karmi from the Hebrew University, and we developed a model. In this model, we take 2 individuals at random from the population. And these individuals, we are all related. So we just need to go enough generations and we'll be related somehow. So we simulated that and assume that these 2 individuals are related G generations ago. Then we looked, can we identify enough of these IBD segments to call correctly their distance? And then repeating this process, not just between 2 individuals, but between 1 individual and all the individuals in our simulated database that encompasses X% of the population. To make it a bit clearer, we simulated a case where the database has 0.5% of the entire population, 1%, 1%, and so on, right? And we did that with a parametric model. We assume that we sample at random from the population, and everything is basically with no population structure. Everyone marries everyone else. Here are the results that we obtained. So here you see the probability to find a match as a function of the size of the database coverage of the population. So the probability to find that you have at least first cousin, second cousin, third cousin, and fourth cousin. Now it's pretty amazing. For a database of only 1% of the population, right? So a database in Israel, that will be 100,000 people. If you have a genetic database like that, you have about 90% chance of finding third cousins in this database for any random person you take from the population. If you have a database of 2%, forget about it. Virtually anyone will have a third cousin match. So that's basically where we are in the US for many of the genetic databases. So for the US, at least for these genetic databases, virtually any person with European heritage, we estimate that by now, that in 2022, we can find a third cousin. So this technique is extremely powerful. You give me the DNA of someone that you don't know who is this person, I will find you a third cousin match to this person. But now you might ask yourself, okay, and if that's great, how can you go from a third cousin all the way to the person? And I'm going to show that quite easy according to our analysis. So in the US, you have about 325 million people. Let's say that there is one of them is your person of interest. And if you have a third cousin match, we analyzed the familial structure of this population. We estimate that it reduces your search space to 850 individuals. Really, really powerful. Then if you have something, you know something about the geography, where this person resides. And by the way, most serial killers operate within 20 miles of their home. But let's say that you even take 100 miles of the person's home. If you basically simulate how many third cousins will be within 100 miles of a specific location that you're analyzing, this will reduce your search space to 370 kilometers. Sorry, this will reduce your search space to 370 people by looking at 100 miles radius around the person of interest. And then if you know something about the age of the individual, you know something about the decade that this person, you're looking for someone in his 60s, in his 40s, or something like that, this will reduce the search space to 33 individuals on average. And if you know the sex, because you can look at the X or Y chromosomes, then it will be 16.5 individuals on average. So you see how with 3 demographic identifiers plus the third cousin match, I can go very close to the person. And from now, I can just use regular police techniques I don't know, maybe put like Pegasus or something, right, on all these like cell phones. You cannot say today, and then you can really get to the actual killer that you're looking for. So I showed you basically how we can identify second or third cousins to virtually every person in the US if you give me their DNA just by internet searches. And I showed you that after you have this match to the second or third cousin, using basic demographic information, you can substantially narrow the search space and get very close to your individual. So that's a very powerful method. What we can do with it, what we can do against it. So one thing that we suggested is to differentiate between the good and the bad actors. These genetic data sets that you can download are produced by a handful of legitimate labs. There are only a handful of providers. What if all these providers will sign using cryptographic signature the genetic data, will publish, so they will have it with a private key, and they will publish the public key online, so these third-party databases can verify that the genetic data was produced by a legitimate lab and not by an illegitimate lab. How it would look like? Super simple. Here's the genetic data. And we will just add one more line to this data, which is the signature. So we'll sign the file. The lab that produces the data will sign it. It will be seamless for the user. The user will upload the data to, let's say, GEDmatch. GEDmatch will validate the signature using the public key of the entity that produced the data. And only trusted entities will be, of course, validated. And they will allow for the searches. If it's an invalid lab, they will say, hold on, we're not searching database. Why don't we do a different onboarding process? So we published this manuscript in Science, this research a few years ago. And this was done with Tal Shor, that the data was at MyHeritage, Itzik Per at Columbia University, and Shai Karmi from the Hebrew University. And with that, I'd be happy to take any questions. Thank you so much.
Thank you, Yaniv. One question, can this be done in Israel? The regulation here is different.
Yeah. The question is like, you ask about regulation. One concern that I have is that, think about that you have the Israeli population is quite small and the fertility rate is higher. So you need a smaller database to identify everyone in Israel. So one option, like what happens if we have the PSIFAS database when it will be ready, if it leaks, and then it might be able to identify individuals in Israel, like you'll be able to identify these participants. It doesn't mean that you should not do PSIFAS, but you should be aware about the privacy concerns. So I think this can be done in, like, for your question, yes, it can be done in Israel.
So, of course, your talk raises, a lot of concern. What would be the worst case scenario in terms of what could happen?
Yeah, it means different things to different people. One worst case scenario, think about you have a covert operation somewhere, one of like specific country without naming names. And it's very hard not to leave your DNA behind. So you left your DNA behind. These people in this country, they are smart as us. That's the assumption that we should have. And if they are smart as us, they will take the data, will upload it to one of, let's say to GEDmatch, and then we're able to identify who is this person in the covert operation, exposing the identity, which puts in jeopardy this person, his or her family. So that's something that you really want to avoid. That could be one scenario, right? Another scenario is that someone goes to his house, found the DNA marks of the person that his wife cheats with him, and can identify this person, right? That could be also. It means different things to different people. What is at risk? But I think we have a way to solve it, right? Just like this solution needs to be adopted, and that's like part of the motivation of the study. That's something that can be done as a community to solve the problem using cryptographic signatures.
One question, to what point do you predict we could narrow searches down to one person purely based on genetic data?
I think it will be very hard to get it to one person. Think about it as kind of like as a geographical triangulation. Okay, so in geographical triangulation, you have kind of like you cut something from one, like, you know, like if you get, okay, like certain distance from one kind of like lighthouse. Let's say you have like a certain lighthouse in this geographical area, and you know that someone is from one specific area from this lighthouse and from a different distance from a different lighthouse. And you can like create two circles and say, okay, this is where the person resides. You can do the same thing by looking at your genetic distance from one relative from your father's side and one relative from your mother's side. You and your siblings are the only people in the world that has a specific, can be described by being like second cousins of someone from your mother's side and third cousins from someone from your father's side. But these are all your siblings. They share the same similar genetic distances. So I cannot narrow it down to one person, but I can narrow it down to sheep. That's the best that usually that we can do, unless you don't have any siblings, and then we can narrow it down to one person.